starting from this video, we try to simplify or to find the partial fractions completely for problems under each category. So for the first one, let's consider this problem, which is an improper fraction, and you can see that the denominator can be factored out into linear factors like this. So from the knowledge we had in the previous video, we can see that it falls under the first category. So we can allocate partial fractions like a over x. This is just a, not a1. You can use whatever the variable name you prefer, but make sure that you are not repeating that variable name in anywhere else. Okay, right? So we can write it as a1 divided by x, and b over this one, and c over this one, because all these things are non-repeated linear factors, right? Now let's see how we should find what is the suitable method to find these a, b and c. Now to compute these a, b and c also, there are two methods. Okay. It looks like this is a very complicated theory, but once you get the big picture, it's just a matter of doing the calculation. Okay, so don't worry just because we have a like a long theory, but it's just a very simple calculation at the end. Okay, so what we should do is we should see whether it is an improper fraction, and if it is improper, we should see the denominator, and according to the nature of the denominator, we just allocate these portions. And then there are basically like two very simple techniques to find these a, b and c. That's all, right? So the first technique is to, now for both first and the second techniques, first of all we should multiply everything by the factors of this one. Now you can even write down this denominator as this one. Okay, this one. Okay, so since the denominator can be factored out into these three portions, you can write down the denominator like this also, right? So if we multiply both left hand side and the right hand side, in other words, if you multiply this equation, if you multiply that equation by these three factors, then the left hand side, like in the left hand side, if you are multiplying with this product, then that product along with this denominator will get cancels out. So what remains is the numerator of the left hand side. And for the right hand side, if we multiply, now like as we are multiplying this equation throughout, we should multiply each and every term in the right hand side by this product. Okay, so when we are multiplying every term by this product, for the first one, this x along with this one will get cancels out. So what will remain is a times 2x minus 1 plus x plus 2, because this x with this one will get cancels out. And for b, for the second one, this term along with this term will get cancels out. So what will remain is x and x plus 2, right? X and x plus 2. And for the third term, we have x plus 2 in the denominator, so it will be cancelled out with this one. So what remains is x times 2x minus 1. Okay, and then we just have to simplify these brackets. Then you will obtain this one. And then what you should do is, we have to write, now this is the method that we should do. Okay, so you have to be familiar with this technique. So the next step is to separate out the coefficients of x squared, x and the constant individually. In other words, for x squared, we will have, from this bracket you will get 2a, okay, and from this bracket you will have plus b, and from this bracket you will have 2c. In other words, this will be the total x squared terms in this equation, okay, and we should do the same thing for x as well as for the constants. Now when it comes to x, this forms 2ax squared, and this will form, let me choose a different color, this will choose 3ax, right? 3ax. See here, 3ax acts as a coefficient for x, right? So we are writing down all the coefficients of x together, and here we wrote all the coefficients of x squared together. And when it comes to x, here it becomes 3a, and here we have 2b, right? 2b, and in here you have negative c, right? Okay, and how about the constants? With this multiplication, it will form negative 2a, and you don't have any constants for the multiplication with b and this, for the multiplication in between b and this bracket, you don't have any constant terms, and here also you will not get any constant term, okay, right? Now the hard part is over. So what we have done is, we have written down x squared plus 2x minus 1 in this format. Now see, this one and this one should be exactly the same format, right? Oh, these two should be the exact, these two should be exactly the same equation or the same expression, right? In other words, the coefficient of x squared should be the same as the coefficient of x squared in the right hand side, and the coefficient of x in the left hand side should be equal to the coefficient of the x in right hand side, and also the same goes with the constants as well, right? So what we can do is, we can say, by comparing the coefficients of x squared, we have here it is 1, and here it is 2a plus b plus 2c, and the coefficients of x will be, here it is 2, and in the right hand side it will be 3a plus 2b minus c, okay, and constants in the left hand side it is negative 1, and in the right hand side it is negative 2a, right? So we have 3 equations and 3 unknowns. So it's just a matter of solving these linear equations, and it is very easy, right? Normally if you get a question like this, especially in exams, the simplification will not be that bad, okay? Now see, to simplify these 3 equations, we can start from the third one, right? So for the third equation, directly we can say a is equal to half. Okay, and then by substituting a in these two equations, 1 and 2 becomes like I have substituted a in 1 and 2, so those two equations will be equal to this one, right? And then here you have two equations with two unknowns, and by simplifying these two equations you can figure out the values of b and c, where in this case b should be equal to 1 over 5 and c should be equal to negative 1 over 10. Please do this calculation also, right? Okay, so that means we have figured out a, b and c. Therefore we can easily write down the complete partial fraction of our given expression, where a, since a is half, we can write it like half over x, and since b is equal to 1 over 5, we have 1 over 5 2x minus 1, and for c we have negative 1 over 10, which is this one. And also we can write down another step where you you can take this 2 also to the denominator of our original term, so you can write it down like this, 2x minus 1 and will be negative 1 over 10 times x plus 2. Okay, so this is the complete answer for the partial fraction of our given improper rational function. Okay, now remember I said to solve for these a, b and c, I said there are two methods. Okay, so this is the first way of doing it. We just multiply with the denominator and then take the coefficients of similar terms together and then compare the coefficients from left hand side and the right hand side. Then we will obtain a system of linear equations where we can solve for a, b and c. Okay, right. And the second method is for this multiplication. Now for both first method and the second method, we will need this first step of the multiplication. Okay, and the second method will be, for this multiplication we substitute certain values for x, right? Now what I mean by certain values is we substitute the roots of this factorization, or in other words the roots of the denominator. How do we find the roots of the denominator? We just equate this one to 0 and compute the required x values. So in this case the x values will be x equals 0, x equals half and x equals negative 2. Okay, because when we substitute these values, then one out of these three factors will become 0 for each and every substitution. Say if we I will describe it now. By substitute x equals 0, and let's see what will happen. So when you substitute x equals 0, the left hand side, this becomes 0 and this becomes 0, so you will have negative 1. And here by substituting x equals 0, this becomes 0, so the total thing will be equal to 0, and this becomes 0, so the total thing will be equal to 0. That means the only term which remains will be a, right? And here by substituting x equals 0, this term will be 0, and therefore we will get a times 0 minus 1 times, here again it is 0 plus 2, right? That is a is equal to, sorry, negative 1 is equal to a times negative 2. Therefore, a is equal to half. You just take negative 1, negative 2 to the other side, right? See, you might feel that this is a very easy method when compared with the previous one I described. Okay, that's true. But the thing is, that is true only for this particular example. But you might get an example where you will find it much easy to do the calculation as it was in the previous method that I described. Okay, we will see those examples later on, and sometimes we might need to apply both methods to compute A, B and C. Okay, you will eventually come across those types of problems, right? Okay, so we have substituted x equals 0, and then we can substitute the other root. So when you substitute x equals half, this term will be equal to 0. So this term will be equal to 0, that means this vanishes, and this term will be equal to 0, that means this vanishes. So you will have only b, and you have to compute the right hand side accordingly. Okay, so when you substitute x equals half, then the right hand side, this one will be 1 over 4, this one will be 2 times half, that is 1, together with this negative 1 it will be 0. So altogether the left hand side will be equal to 1 over 4. This is 0, this is 0, and the second term will be b times half plus 2. Okay, so by solving this one, you will get b is equal to the previous answer that we got, which is 1 over 5. Okay, and similarly, by substituting the other root, which is x equals to negative 2, you can see this term will vanish and this term will vanish because of x plus 2 term, and you will have only this one. So from that you can find out the value of c. So when you substitute x equals negative 2, the left hand side becomes negative 2 squared is 4 plus negative 2 times 2 becomes negative 4, and it is just negative 1. And since these first two terms vanishes, you will have c times negative 2 times for this one you will have negative 4 minus 1, right? And by solving this one for c, you will get c is equal to negative 1 over 10, right? So these are the exact answers that you got by solving in the other method as well, right? So once you compute a, b and c, then you have to substitute it appropriately in these partial fractions and write down the final answer. Okay, right, and we will see some more examples in the next videos as well.